A cylinder head assembly has a very tough job. It must seal the top of the block while allowing its valves to open and close millions of times in the lifespan of the engine. The valves are exposed to a combustion flame hot enough to melt steel into butter. Obviously, the slightest repair mistake when working on a cylinder head could be disastrous to you and to the car owner. This video will summarize the most important steps for reconditioning a cylinder head. Most of the tasks illustrated in this video can be done with equipment found in a typical auto shop. However, some of the machining operations might require the specialized equipment and expertise of the machine shop. Cylinder head disassembly, part inspection, measurement, grinding valves, grinding and cutting seats, and reassembly will all be demonstrated. The procedures in this video are typical and apply to most makes of cylinder heads. However, always refer to the engine manufacturer's service manual for exact specs and procedures. Other videos in this series explain engine teardown, front-end service, short block service, engine reassembly, and other related service tasks. This series of videos will help you become a more competent, profitable engine technician. It will also help you pass the ASE Engine Repair Certification Test. After removing the head from the block, mount it on a cylinder head stand. Remove the rocker arms and cam followers if needed. When rocker studs are used, the heads will usually come off with rockers intact. Before removing the valves, use a scraper to remove excess carbon from the valve heads and the combustion chambers. Then use a power brush to clean the combustion chambers. Power brushing now will help protect the seat from damage and will also save cleaning time once the valves are removed. Strike the spring retainers with a brass hammer to help free them from the keepers. They can stick after prolonged service. Use your valve spring compressor to collapse the valve springs and free the keepers from the valve stems. Make sure the pad of the tool is on the center of the valve head. The fork end of the tool fits over the retainer. You must collapse the spring and the retainer to free the small keepers from the grooves in the valve stem. Hold the valve spring compressor securely as you compress the spring. Then use your fingers to free the keepers from the stem. Wear safety glasses in case the compressor slips off the retainer and the spring shoots out. Repeat this procedure on the other valve springs, remembering to hold the spring compressor securely. If it flexes sideways, the spring can fly off with considerable force. As parts are removed, keep them organized in sequence on your workbench. Parts can be select fit at the factory, and this will also aid problem analysis. If you find trouble with one component, it could affect another component in that same combustion chamber. Here's a spring that's stuck to the seal. A screwdriver will free it from the hardened valve stem seal. Pop the seal off the valve stems. If umbrella seals are used, slide them off the stems. Never force the valves out of the guides if they seem to stick. The tip of the valve stem may be mushroomed or enlarged from wear. If a valve will not slide out, don't force it, or you can crack the valve guide or head. File a chamfer on the valve tip so that the valve will slide out freely. Before complete valve removal, check valve guide wear. To get a general idea of wear, simply wiggle the valves in their guides. If they are tight and do not wiggle, guide service is not needed. Mark any guides that are loose so that they can be knurled or replaced. If any guides are questionable, use a small hole gauge to measure exact wear. Measure at the top, bottom, and center of the guides. The guide will normally wear more at the bottom and top and less near the middle. Compare your measurements to specifications to determine if valve guide service is required. As you remove each valve, place them in order on your bench or place them in an organizing tray. Stems should be select fit and wear patterns should be rematched during reassembly. Without nicking or gouging the head gasket surface, especially if soft aluminum, scrape off the gasket surfaces of the head. To final clean the head gasket surface, use a long sanding board to scuff the surface of the head lightly with 220 grit sandpaper. Use a spring-type cleaning tool to remove carbon from inside the valve guides. It will shear off carbon deposits. Mount the tool in an electric or air drill and move the tool up and down to clean out deposits from the guides. Next, use a brush-type tool in the valve guide. It will remove any remaining deposits. Again, mount this brush in an electric or air drill. If engine overheating was indicated, or if you have an aluminum head, you should check the head for warpage. Place a straight edge on the head and try to slide a feeler gauge under the straight edge. Depending upon specs, a 3 to 5,000th feeler gauge is normally used. If it will slip under the straight edge and head, machining is required. You should also check the intake and exhaust manifold mating surfaces for warpage. Also, inspect the head for signs of damage. If overheated, small cracks can form in or near the combustion chambers. Some cracks cannot be seen with visual inspection. Magnetic particle inspection would be needed. An electromagnet is placed on the head. Particles of iron are then sprinkled over the head. A magnetic field will form in any crack and attract the particles, so the crack becomes visible. Note how this crack shows up after particle inspection. With aluminum heads, dye penetrant inspection is needed to find cracks because aluminum is not magnetic. First, spray cleaner over the head, then wipe off the cleaner. Next, spray dye penetrant over the head. This dye will soak into any cracks. Wipe off the dye penetrant after allowing sufficient soaking time. Finally, spray on the developer. This will make the penetrant change color, usually turning it red. As you can see, this small crack became visible after the developer worked on the penetrant. Before grinding any of the valves, inspect them closely. Check for thin margins, burned or cracked valve faces, worn stems, and worn valve tips. Here's an example of a worn tip that would require replacement. This is a badly burned valve that resulted from engine overheating. It would definitely require replacement. This valve was bent because of a weak valve spring. This valve floated and was hit by the upward moving piston. Visible signs of valve stem wear like this would require miking. When in doubt, always measure stem diameter. This will let you make sure that stem to guide clearance is within specs. A loose valve can cause a lifter-like tapping noise, oil consumption, and possibly valve failure. Replace any valves with these types of problems. Compare old and new valve dimensions carefully. Before grinding the valves, finish cleaning them. You can use a wire wheel on a bench grinder. Wear safety glasses and gloves for protection. First, use the wire wheel to remove any remaining carbon from the valve head. Then, use the wire wheel to clean the carbon from the end of the valve stem and the bottom side of the valve head. Be careful to not let the valve catch in the wire wheel. Bead blast equipment will also clean carbon from the valves efficiently. To use a valve grind machine, begin by dressing the grinding stone. Move the diamond dressing tool in front of the stone and use a wrench to lock it down. Stone dressing is needed any time a complete set of valves have been resurfaced. Turn on the machine and carefully feed the diamond toward the stone. Slow down as you near the stone. If you feed the diamond onto the stone too quickly, the diamond tool and the stone can be damaged. Turn on the coolant and very slowly move the diamond until it just touches the stone. Then use the lever to move the diamond back and forth over the stone to true its surface. Only remove as little material as possible. Excess dressing will reduce stone life. Next, set the chuck angle. Loosen the hold down and swing the chuck to the correct face angle, usually 30 or 45 degrees. You may add a 1/2 to 1 1/2 interference angle on the chuck head, if desired, to narrow the valve to seat contact point. Lock down the chuck head after setting it to the correct angle. Install the valve in the chuck. Then carefully set the stem depth adjustment. It is on the back of the chuck head. The jaws of the chuck must grasp the machined portion of the stem near the valve head. If you slide the valve in too far, the chuck will grasp the unmachined portion of the stem, and face runout will result. Use the machine's lever to move the valve in front of the stone. Carefully use the hand wheel to feed the valve up next to the stone, but not into the stone. Turn on the coolant and set it to flow down over the valve head. Slowly feed the valve into the stone. Once the valve starts grinding, move the valve back and forth over the stone, while keeping it in constant contact with the stone face. Grind off as little material as needed. Simply grind until all of the valve face is cleaned up and shining. You can use marked divisions on the hand wheel to note how much material has been ground off each valve. Try to grind each valve equally. This will simplify head reassembly when you are trying to shim the valve springs. Repeat this operation on the other valves. Remember to keep the valve in constant contact with the stone. Don't move it over to the right or left of the stone. Back the valve away when done and re-inspect your valve face. Use the other end of the machine to resurface the valve stem tips. Grind only enough of the tip to clean it. Again, try to grind each valve the same amount. After grinding the tip, rechamfer the tip as shown. If excess grinding was needed on the face or the tip, replace the valve. This valve grind machine also has an attachment for resurfacing the rocker arm tips. To use stones to grind cylinder head seats, select a stone slightly larger than the seat. Mount it on the arbor and dress the stone face. Set the dressing tool to the correct angle. Then adjust the diamond up next to the stone. Install a power head and spin the stone on the arbor. Slowly feed the diamond into the stone. Then move the lever to remove a thin layer of material and clean up the stone face. Next, install the correct diameter pilot in the guide. Push the pilot down while twisting. Oil the pilot, then set a dampening spring over the pilot. Slide the stone and arbor into place. Use the power head to spin the stone on the seat. Don't push down. Let the weight of the tool do the work. Only grind enough metal to clean up the seat face and make it shiny all the way around. Carbon cutters can also be used to recondition cylinder head seats. We will use them to demonstrate a 3-angle valve job. The cutters come in various diameters and angles. You must select the right size and angle cutter for the specific type of head. A T-handle is provided for turning the cutters. Pilots are provided for holding the cutters in place. It is critical that you use the correct diameter pilot. Sizes are usually marked on each pilot. The pilot must not slide into the guide too far, nor not enough. Typically, the pilot should slide in about 1/4 inch from the end of the guide. Pilot selection is critical to your valve job because it centers the cutter in the seat. Fit the pilot into the guide. Then use your T-type wrench to push down and twist and install the pilot properly. A 3-angle valve job involves cutting 3 angles on the valve seat. This rounds the seat and increases engine horsepower. Select the right cutter and adjust the carbide cutters in or out as needed. Each cutter face must contact the seat only, and they must not hit the combustion chamber walls. First, use the 60-degree angle cutter to remove metal from the inside diameter of the seat. This will narrow and move the seat contact point out on the valve face. Install the T-handle and use both hands to rotate the cutter on the seat. Be careful to not place a side load on the pilot and only push down lightly. If you place a side load on the T-handle, seat runout and valve leakage can result. Remove the cutter after a few rotations and check the seat. Note how it is clean on the inside diameter. Next, use the 15 or 30-degree cutter on the seat. Only remove enough material to clean it up. Again, turn the T-handle carefully using both hands. Note how the seat has been cut on the top and the bottom, but the face of the seat has not been resurfaced. Depending upon valve angle, use the 45 or sometimes 30-degree cutter to true the seat face. This surface will contact the valve and produce the combustion seal. Rotate the cutter until the complete surface of the seat is cleaned up and shiny. This last cut will produce a precision 3-angle valve job to increase flow over the valve and improve engine breathing and horsepower. Again, the seat should be perfectly shiny and clean with no black pits. Recut as needed. Before cutting the next seat, use a small brush to clean out the metal shavings inside the cutter teeth. You don't want the metal shavings to upset the cutting action. A power unit is also available for turning the seat cutters. It is used like the power head discussed for stones, and it will increase work speed. Before starting head reassembly, carefully wash all parts in solvent. You must remove all stone grit and metal shavings, or part damage and wear can result upon engine starting. Wash the head and all of its related parts thoroughly. To check the valve seat-to-face contact point, wipe Prussian blue on the valve faces. This will turn them dark. Prussian blue will allow you to check where the valve face contacts the valve seat. Install a valve in its guide and use your fingers to slap the valve down a few times on the seat. Remove the valve and inspect the mark made on the valve face. The mark line should be near the outer center of the valve face and should go completely around the valve. If needed, use the appropriate cutter to widen or narrow the seat to make the seat contact the valve properly. Springs weaken after prolonged service, so check them carefully. Check spring tension and compare to specs. If pressure is low, replace the springs. Place the springs next to a square and rotate them. If not straight or square, they should be replaced. Another way to check general valve spring condition is with a straight edge. Place the straight edge on the springs as shown. If their lengths vary, they should be replaced as a set. Some service manuals recommend measuring spring-free length with sliding calipers. This is a more accurate check than a straight edge. To determine if the springs need to be shimmed, install a valve, spring seat, retainer, and the keepers. This will let you measure spring installed height, or the distance from the spring seat to the bottom of the retainer. Measure from the seat to the retainer. If not within specs, place a shim under the spring to bring the spring installed height to within specifications. Valve and seat grinding tends to increase this dimension, which also lowers spring tension. Therefore, spring shims are often needed. Install the shim of correct thickness. If valve rotators are used, check their condition. They should be unworn and turn freely. To reassemble a cylinder head, remove a valve from its tray. Oil the valve stem thoroughly, then slide the valve down into its correct guide. Again, keep the valves in order because valve stems could be select fit at the factory. Repeat this operation on the other valves. Oiling is needed to prevent valve and guide wear upon engine startup. Next, install a rotator or seat over the valve guide. Slide an umbrella-type valve seal on next. If the seal is a positive locking type, you'll have to use a tool to force the seal over the end of the guide and lock it into place. When installing a valve spring, make sure you don't install it upside down. Many springs have a top and a bottom. The tapered end of the spring goes up. Install the retainer and compress the springs. Remember to hold your valve spring compressor securely to prevent the spring from slipping out from under the compressor. Use your fingers to fit the keepers into the stem groove. Install the bottom one first and hold it in place. Then drop the top keeper into its groove and release the compressor. Make sure both keepers are locked down completely into their groove. If the valves use small O-ring type valve seals, you must change assembly procedures to prevent seal damage and oil consumption. Compress the spring before installing the seal. With the spring compressed, slide the small seal down over the stem and into the lower groove in the stem. Then, fit the keepers into place and release the spring compressor. If you accidentally install the O-ring seal first, it can be cut and ruined when you compress the spring. Use a plastic hammer to strike the valve stem tips. This will seat the keepers and check their installation. You don't want a valve to drop down into the cylinder during engine operation. To check your valve job, pour clean solvent or water down into the cylinder head ports. Then inspect around the valve heads for signs of leakage or weepage. If any of the valves are leaking, remove them and correct the problem. You should now have a good understanding of cylinder head service.